Before we move on to page 2, make sure that for all of these blanks that you have in problems number 2 and 3 that you include units for all of these, such as radians per second, hertz, degrees or radians, milliseconds or seconds, voltage, watts, or volts and watts rather. And let's go ahead and use 3 significant figures for all of your answers, unless it is an exact integer, but don't include pi in any of your answers. Use 3 significant figures instead of including pi in answers if it comes out that way. And make sure that you have units for all of your answers. On page 2, homework 5, page 2, problem 4. You want to use power is equal to IV, or I squared R, or V squared over R. And remember that the RMS values are equal to 1 over the square root of 2 times the peak values. You're going to use this for both problems 4 and problem number 5. All you really need to do on this problem is find the average power for both of those problems. And problem number 6 and problem 7, I'm going to work an example problem like these on a separate page in a moment. I just want to make sure that if you're using version 4 of the textbook, that you be sure on this problem to use a period of 12 milliseconds. You're asked to find the voltage and the current in terms of a cosine function, and that means that what you're really looking for is the peak value, the angular frequency, and the phase. So suppose that in this similar example I'm giving that you have an RMS value of this. Now this is not what you would put right there. You're really looking to put numbers there, there, and there in the blanks provided right here. So you're looking to put a number right here, a number right there times time, and plus another number right there in degrees. So this should be in radians per second, this should be in degrees, and this should be in volts. Same kind of thing down here, except you want to put amps, radians per second value right here times time, plus some number in degrees. Alright, back over here to the example I gave you, and it's similar to those, and for this one you can say that the RMS value is equal to 1 over the square root of 2 times Vm, so that if you're looking for Vm, it's simply the square root of 2 times the RMS value. That's how you would do that one. And to find the omega, that was the next step, the next thing we need to do. And omega is equal to 2 pi f, and that's equal to 2 pi divided by capital T. So if you put this in seconds, make sure that you take that milli out of that. Make sure you write it, for example, 10 times 10 to the minus 3 milliseconds. I think one of the examples is microseconds, and that's 10 to the minus 6. Make sure you put that in here, and you want to get an answer in radians per second. So not radians per millisecond or radians per microsecond, but omega should be in radians per second. So that goes fairly quickly. The longest part is dealing with how do you find the phase based on this time for the first peak. This is similar to the example I showed in the other video, in which you say that if you have the peak value Vm, you're just plugging in T sub p throughout this. And remember that you just divide both sides by Vm, and that you get 1 equals cosine omega Tp plus theta. Inverse cosine of both sides. The time for the first peak we have found, in most cases, this to be 2 pi. It may not always be that way, so let's just get a general expression for that. Well, wait a minute. You're asked to find theta, not T sub p. So theta is equal to cosine minus 1, inverse cosine of 1, and then minus omega t sub p. So you would take this omega value you have here and put it there. You would take the t value and put it right here. And what you want to do is make sure that you look at the values right here that you can possibly have for this. You know, it could be 0 or 2 pi, not 25. What was I thinking? 4 pi. You could even have minus 2 pi. I don't really know if you need to go in that direction. No, I can't imagine that you'd be doing that. Alright, so you're going to get an answer here that's in radians. You know, some value in radians when you get this. Let's go ahead and convert that over to degrees once you get an answer using pi radian equals 180 degrees. And just make sure, let's decide this as a class, that the theta values that we should have, I think, yeah, less than 180 degrees. Yeah, let's, you know, as a class, let's decide to force our values to pick values up here that will lead to a phase angle with that's in that range.